Okay, so we're going to start up on probability. We're actually not even doing probability today, but basically what I'm going to do is I'm going to teach you guys how to count fast today, because with probability, we're going to be looking at events that can occur in so many ways that trying to count them all would be quite tedious. So for this particular lesson, we're going to talk about how to count things really fast, okay? So basically, we're going to be looking at how many different ways something can happen. All right, you don't need to write this, but I just thought I'd give you a little story problem here to kind of put it into some context for you. It says, Johnny is a car salesman. He only sells 3 types of cars, and each car comes in one of 2 different colors. Now, obviously, nobody sells cars like that, but just to make it easier, we're going to talk about it like that. So he sells 3 types of cars, and each one come in 2 different colors. So how many possible cars could you get? 6. Here's why. Because you have 2 options to make, right? First of all, you have what type of car, right? And then you have what color. Now, how many ways can the first choice be made? 3 ways, right? Now, how many ways can the second choice be made? 2 ways for each one of those, right? So how do you get your final answer? Yeah, you would multiply those. So what's the shortcut for counting is multiplying your choices together. If I can make this choice in this many ways, the next choice in this many ways, if I multiply, I can get the total number of choices super quick. Now, this is a tree chart. You guys probably seen that back in junior high. I probably won't be spending too long with that, but I just wanted to make that connection for you. You guys can see visually here why it's 2 times 3 and why it equals 6 at the end, right? So there you go. All right, now this is basically the fundamental counting rule, and I don't think you guys really need to write it down. I don't think it's going to edify your notes at all, but it's just something to keep in mind. If one selection can happen in m ways, meaning it's a variable, right? Could happen in some unknown number of ways, and a second selection can happen in n ways, there's your other variable we don't know, then to find the total number of ways those 2 selections can be made together is by multiplying them, m times n. Okay, that's the fundamental counting principle. Okay? All right, so we're just going to go ahead and jump right into some examples. So go ahead and write down number 1, please. So when you go to Jimmy's Burger Joint, you can get an appetizer, a meal, and a dessert for $10.99. If there are 5 appetizers, 5 meals, and 3 different desserts, how many different kinds of meals can you get? Some of you guys have got the answer already. 75 is right. Let's see how that is. First of all, we have to ask ourselves, how many different choices do I have to make to solve this problem?
5 appetizers.
I have to make 3 choices, right? I need to make a choice of what I'm going to have for an appetizer. I need to make a choice for what I'm going to have for the main course, the meal. And then I need to make another choice for what I'm going to have for the dessert, right? Okay, now that's the number of choices I have to make, right? But now we have to look at how many ways can I make each one of those choices. How many options do I have for an appetizer?
5.
How about a meal?
5.
How about a dessert?
3.
And so to find the total number of ways, for every appetizer I choose, I have 5 meals that can go with it. So that's 5 times 5 possibilities right there, which is 25. And for each one of those 25 outcomes, I can have 3 desserts. So if I multiply my answer by 3, that'll give me the total number of possible meals for $10.99, which comes out to be 75 different meals. Okay, now let's read this. You're taking a multiple choice test with 10 questions, and each question has 4 options. How many different ways can you fill in the bubbles? Don't say your answer out loud. I don't want you to get embarrassed if you say this. That's why. Here's what I want to say. Really common answer is 40, and it's wrong. It's not 40. And here's what the thinking is. Well, Mr. Bailey, we multiplied the 3 numbers in number 1, so we're just going to multiply the 2 numbers in number 2. That's not true. We need to think about what we're doing here. Let's read this. You're taking a multiple choice test with 10 questions. Each question has 4 options. How many different ways can you fill in the bubbles? Now, here's my first thing. What did I do in number 1? I said, how many times do I have to make a choice? I had to make one for an appetizer, a meal, and a dessert. Now let me ask you this. How many times do I need to make a choice?
10 times.
I have to make a choice 10 times. It's a 10-question test, right? I have to make a choice for question 1, question 2, question 3, 4, 5, 6, 7, 8, 9, 10. Now, how many ways can I bubble in for the first question? 4. How about for the second one?
400.
The third one? 4th, 5th, 6th, 7th, 8th, 9th, 10th. Now, we're multiplying all those. In other words, 4 multiplied by itself 4 times, that's 4 to the 10th power. And that is not 400 either. I heard somebody shouting that out. It's a pretty big number, actually. 4 raised to the power of 10 is 1048576.
So, like, on our benchmark test, is that something?
So, there you guys go. You need to ask yourself this. How many times am I making a choice? Draw that many blanks. And then for each one of those choices, I need you to put in the blanks how many ways that choice can occur. Okay? So, as you guys can see then, there's a million ways you can fill out a 10-question, 4-option test. Okay? It's a lot.